Last but not least, Marauder Robotics, presented by Dennis.
My name is Dennis Yancey, and I'm going to tell you what Marauder Robotics is doing to bring balance to kelp ecosystems. 3 billion people rely on healthy oceans in order to provide fish as a source of their protein. Over 500 million people rely on it as a source of income. In order to maintain a healthy kelp ecosystem, there's a delicate balance between predators and urchins. In our case, the predators are being overfished, and they're being displaced, causing this ecosystem to collapse. It collapses into what we see here is an urchin barren. It's devoid of biodiversity, and there are no fish as far as the eye can see. And this is expanding on 6 continents at an ever-increasing pace. It's showing up in places that it never existed before. This affects coastal communities in the fact that it reduces the mitigation, storm mitigation. It reduces the food stability, and it reduces how greenhouse gases and ocean acidity is mitigated in regional regions. In order to reverse these trends, we need to do either one of 2 things. We need to either stop fishing, or we need to produce a technical solution that's scalable. And that's where Marauder comes into play. We're developing a autonomous underwater predator that can be scaled on a global stage. It reduces urchin populations to less than 2 per square meter. We're developing it in 4 technology modules: hardware, computer vision, acquisition, and processing, and eventually want to integrate those systems. When we compare it to the current state of the art, the diver, it takes 1 robot to replace 75 divers. It can work all day, and more importantly, it can work at night when urchins are active and they're exposed. We can do this at depth for longer periods of time at a fraction of the cost, and we can effectively scale this to a global scale. We are partnered with 3 pilot partners. They're supporting us on our first deployment in December 1st through the 8th. More importantly, they are the channel to our first customers, both in industry and government. We are partnered with Georgia Tech, which has 20 years of experience building hardware and navigational software. We're adding our experience as hardware providers and software providers. Thank you.
Questions?
Quickly, can it be applied, or do you see an application for systems outside of your temperate zones where kelp beds exist? You may have, in other areas, invasive species. Can it be, is it modular enough, flexible enough to apply to other areas?
We are building it in a modular fashion, and the reason we are doing that is so that you can develop a new module and basically plug and play. But it's going to take different skill sets, different functionality to do different targets.
How does the robot identify the urchin?
Computer vision. We're using neural networks in order to determine, spikes, color. It's round with.
So do you ever get any false positives? Collecting things
early
you
on,
don't intend
you're going to get false positive. Okay. We're working those out. But we're close to having a really good system to actually identify the different species: red, purple, green, and black long spiny.
And what do you do with the urchins you collect?
So we're looking at 3 different ways of handling it. We want to either kill them in situ. I personally want to be able to cull the entire species. We can either fatten them up and use them as uni or as animal feed, so aquaculture feed. The exoskeleton is calcium carbonate. It can be used as limestone and concrete. I mean, you want to be able to recycle the entire species.
Other questions?
Yes.
So you've got these devices
Yes.
floating around. I'm guessing they would have some ability to collect data to
Oh.
inform policy. Can you talk to that, and can you also perhaps touch on what the impact is that that this can have on ocean acidification or greenhouse gas emission or something like that?
Well, you're going to be roving around removing urchins on a constant basis. Once you do the actual mitigation, you're going to start collecting data when you're just roving around collecting data on biodiversity, on environmental parameters. I mean, all this stuff can be used in a SaaS model where people are getting real-time data and they're making real-time informed decisions. That's not happening right now with our government. This will also inform industry on what species are out there, how many are there, where they're located. The other part? Ocean acidification. So macroalgae is important in...
Continue the conversation over drinks.
Yes.